Hey, Professor Caps, it's Michael James. Week 8, last lab with you. So what I did is I've got water bottles here that I've left in the freezer for about 2 hours and 45 minutes. Um, I've read online that this experiment won't always work, and I have a feeling that we may have some trouble with this one because I think that my water it appears frozen. I'm not exactly sure. I got three different bottles. Um, if you look at the consistency of this one, I have a feeling that this one is probably liquid right now. But I know that this one right here is definitely all ice. Now, when I took this one out, it did bang. I kind of hit it along the side of the fridge, and I think that might have activated the phase change. Um, so I've got another bottle over here, which is kind of similar as the first one. We can see some crystalline structure forming at the bottom. Um, so for this first one, I'm going to try and activate the pour. We'll see what happens. Okay. Oh wow, it's still liquid. Let me see. No, that's not happening. Okay. Yeah, this one's a solid ice. I must have hit these on my way out. I thought this one was going to be one that poured. It's funny because it looks liquid. It doesn't look like it's ice. So, oh, there we go. Cool. All right, so it looks like um, towards the edge of the bottle, we've got crystalline structure, and towards the center is some liquid. I press the bottle together. Now, when I pour it, it's not forming any sort of. Uh, yeah. Oh, okay. I don't know how well you can see that, but imagine that's pretty cold. Uh, hmm. Got an air bubble frozen in there, so you can see it's not completely completely ice, completely crystalline. Wonder what would happen. I'm gonna. Oh, okay, so that one's yeah. So my initial observation was consistent with what's actually happening. So in this bottle, the outer edges. Oh, there you go. Huh. Cool. So all I had to do was slam it a little bit, and then that caused it to crystallize completely. Now, as for the pour, I'm not getting any uh, any ice formation when I pour it. It's cold though. Let's see what some of these other ones. All right, now these other ones I haven't touched. I'm gonna slam this one just to see what happens. Kind of the same situation as before. Frozen along the edges of the water bottle. Oh, whoa, huh. It's ice cold. I'd say about 20-30% of the bottle by volume is frozen in that one. All right, that didn't work as well as we'd hoped it would. We did when we slammed the bottle, we did see ice form. So I'm going to roll through what happened. All right, so I placed the water bottle in the freezer to get it ice cold. What we're trying to do is lower the temperature of the water below its freezing point and still have it be a liquid consistency. Um, so when we took it out, the water was still liquid, but as soon as we slammed it on the table, or in my case, as soon as I accidentally hit it on the fridge, I think that the liquid underwent a phase change to become a solid. So the water has been cooled below its normal freezing point because we know that our freezers drop below the freezing point of water. And when water freezes, the molecules come together in an orderly way to form a crystalline structure. That's why when you see ice looking as a solid, it's in that crystalline state. So because of this, water molecules as ice have less energy than water molecules in their liquid state. So when water goes from liquid to solid, the molecules lose heat energy. And when the water bottle was tapped or opened, the rest of the water was warmed. And when this heating occurred, about 20% of the water froze, which is why there's a slushy consistency as opposed to a solid chunk of ice. And then when water was cooled to its freezing point, the ice crystals collect in the water. The bottle that was used was pure water, and when an impurity is added to the supercooled water, the crystallization process is going to speed up significantly more so than when it's pure. And then it looks like I used Ice Mountain 100% natural spring water. I tried to go for the purest, and I saw on this bottle it said pure quality, so I was hoping that that would help us out a little bit. Not the case that we'd hoped for, but anyways, thanks for the great semester. Have a good day.